Hi, everyone, and thank you for joining the Rutgers Geology Museum's Ask a Geologist program. So today we have a graduate student from Rutgers University in the Department of Earth and Planetary Sciences, and I'm glad to present Ashlyn Spector to you. She will be talking to us about barrier islands today. So without further ado, go ahead, Ashlyn.
Just needed to unmute myself there. But hi, everyone. So, like Rhea said, we're going to talk about barrier islands. But first, to kind of introduce myself. Um, so, my name is Ashlyn. I'm from Florida. I was born and raised there. That's where I did my undergraduate degree. And now that I'm up here, I'm studying paleoceanography and then as well as science and climate change communication. This is a picture of me when I worked for a summer in some salt marshes down in Georgia. Um, and a little fun fact, my favorite dinosaur is an Allosaurus. But my other favorite dinosaur is my bird Olive. If you hear screaming, that is her. She gets very excited to hear me speaking, but um, jumping right into the topic at hand today, what are barrier islands? So you might have seen through a map or when you were driving this really skinny long strip of land um, that's running kind of right adjacent or alongside the main shore. And this long island that's made of sand, that's separated by this lagoon area, is considered a barrier island. Um, Barrier islands are controlled by a lot of things. These can be the waves, the tides, the amount of sediment or sand, the sea level, and we're going to go over that a little later so you can get a better idea. And so, if we want to kind of get an idea of what's going on with New Jersey and Barrier Islands, we could look at this map on the right here, and we can see kind of with the orange brown area right on the side, the coast. These are all barrier islands. So LBI, Cape May, Atlantic City. If you had to kind of take a bridge to get over, then you're on a barrier island. And so this video right here on the left is just showing a time lapse between 1984 and 2018. Um, from this, you can see this is Barnegat Light, which is right here on the map. And you can just see how the sand is moving through time, and you can kind of see it in the water as well. And it's just showing that barrier islands are really a dynamic system, and they're really great to study because for geology, we like to think on millions of years, but within a lifetime or less than a lifetime, we're able to see change for these islands. So when we're thinking of Barrier Island, we're not just thinking of the island itself, but it's an entire system. Um, so if we start kind of offshore, this is like if we were in the Atlantic and approaching into the mainland, we would first hit our actual island. Along these islands, you can have these little openings that are called inlets. That's where you'll have a lot of boats will go in and out of. And like we saw in this previous video, you see this opening right here being the inlet and all this sand moving in and out right around here. So these are our flood tidal and ebb tidal deltas. This is just demonstrating that the sand isn't really like cemented in place like it is for the mainland. It really can move around. And as we go to the back side of the island, we get this back barrier area. This is going to be something like Barnegat Bay. This is a lagoon. And that as we move to the mainland, we start to hit some marsh area, some tidal flats, really muddy, really vegetated, and then we're back on the mainland. So for this presentation today, we're going to focus mainly on the barrier island itself rather than the entire system, but just know that all of these things interact and influence one another. So here we have another cross section as if we were to kind of cut the barrier island in half, kind of like a cake slice. And moving from right to left, this is going from the offshore, the Atlantic Ocean, back towards the lagoon. So if you're swimming onto the shore, you hit the beach. And, we all know the beach. This is where we go to hang out and play and go in the water. So this is what it looks like in the top right. And as we walk back off of the beach, we start to get into this more hilly area with sand and vegetation. And these are called our sand dunes. And as we walk through those, we then start to see a new kind of environment called a maritime forest. And these are going to be more densely vegetated areas. You have different kinds of scrub rushes and trees. You also get a variety of wildlife. And then as we move back through the forest, we start to get into a more open area, really muddy, more wet as we go towards the lagoon. And this is all our salt marsh area. And so I'm going to expand upon all four of these different areas of the barrier islands in the upcoming slides, but just so you kind of get an idea of the transition of all of these different environments. So, like we were saying, when you come in from the water, you start to hit onto the beach. The beach is this really open area where you can have waves crashing, you have all of this sand, and you also get a variety of wildlife. So you can find seashells, you can see horseshoe crabs. A really important animal that really relies on New Jersey beaches is the plover right here. They're really adorable and they're actually endangered. And a large amount of their nesting grounds yearly are on New Jersey beaches. So, rather than just thinking that, okay, well, barrier islands are important because of the sand, well, all of this impacts, the life that relies on it. So, as we kind of move away from the beach, we start to hit into the dune area. So, when you're on the beach, you might have experienced this when the wind picks up, you kind of feel like you're getting hit with something. And, the sand is able to be picked up since it's really loose and it will kind of be blown over. And so, this is how you're able to get dunes being created on the beach because wind will pick up these really tiny sand grains and blow them over. And over time, they'll start to stack on top of one another and form these dunes. And in order to make sure these dunes are formed and they stay put together, you have to have plants to trap it. Because if you have plants and vegetation in general, it's going to make it harder for sand to move through that and it will start to better stick together. If you don't have any plants and you have just open air like the beach, the sand is able to just kind of blow around wherever. And dunes are really, really important for protecting the islands itself. They're kind of like nature's natural hazard mitigator, and they help people. Because if you have kind of this elevated area, if you have really bad storm waves or winds, like you can see these houses behind here, they're less likely to get immediately damaged or hurt by anything. So that's why it's really important to have, our sea oats down here and different kinds of grasses that can help develop our dunes. So as we move past the dunes and go further into the barrier island, we hit into the maritime forest or marine-like forest. These are really cool and unique areas since they have to be really resilient to salt spray. As you have that wind blowing across the island, it's carrying some of that sea salt. And as we know, trees don't really like to be really salty, they like fresh water. And so on the edges of these forests, they're going to be more resistant or strong against this salt spray. And as you get into the interior, of this area, they're going to be more dense and healthy vegetation. And you have like sand and dirt. It looks more like a sparsed out forest area. You can get raccoons and you can get deer and tortoises. So you also get a lot of different animal life going through here. And if you've ever been to LBI or Sandy Hook, especially, you've probably had to walk through one of these and through the dunes to get to the beach. And so as we move to the final back area of the barrier island, we kind of run into the salt marsh area. I really like salt marshes a lot. They're really, really important, and I'll stress that importance a little later as well. But they have a lot of biodiversity and they're really bioproductive, which means you have a lot of plant and animal life that's doing a lot of hard work. And so we look at this little video on the left, we can see water coming in and water going out. And so this is just showing the influence of tides on salt marshes. So for part of the day, the water will rise up during high tide and cover certain plants and muddy areas. And then as that water goes back out during low tide, it starts to uncover it and expose it to the air. So this is a really interesting dynamic that marshes have that a lot of the life around it has to adapt to. You have certain plants that are used to being covered in water more often than other kinds. You have little crabs and snails that like to interact with the grasses. You'll have cordgrass or Spartina is the name of these, kind of prickly looking green sticking up plants. You also have a lot of bird biodiversity, fish going through. And a really important component of this too is mussels. And these are kind of the mounds you can see here. And these will build up and kind of keep sediment together. And they're also filter feeders. So as this water comes up and the mussels start to feed, the water that they put back out is actually filtered and cleaner than it was before. So they're really important. And something to keep in mind is as sea level continues to rise, the high tide and the low tide values are going to change. And so marshes, we like to study how they're going to adapt and keep up with the changing amount of water, since the plants are already used to where they are currently. So it's a really interesting dynamic that we want to make sure that they stay safe and alive from. So going back to the overarching picture of barrier islands, we have two different types of islands that we can see. And we can really tell this by the shape of them. So we can have really long and skinny islands that have very few openings, very few inlets. These form on coastlines that primarily have a lot of wave action. These waves are able to move sand and sediment down along these island chains and deposit them. And then we also have the other type of barrier islands. We can call these kind of like drumstick islands, in that they're, they're short and stubby and they kind of go back a little further than these longer ones. And these are forming in areas where you have a mixture of wave and tidally dominated areas. So you have more spacing and opening in between. You don't have that as much as a continuous movement of sand down the coast. These can relate to different kinds of tidal range. We don't have to worry about that too much, but it's just another classification and way we can better, as geologists or geomorphologists, better understand what's going on with the coast. So what is New Jersey? Well, if you remember the map we looked at, we kind of had longer and skinnier islands that were forming rather than these kind of drumstick ones that you'll see, especially down in the southeast United States. So here we have a really nice picture demonstrating our drumstick like barrier islands, you can see all of this sand and sediment coming off from the mainland and being moved by the water itself. You can see that they have this really extensive marsh area back here, but they're not as continuously long along the coast. And here we can see our wave-dominated barrier islands. This is the Outer Banks in North Carolina, where they're more continuous and you have very fewer openings. So how exactly do barrier islands form? Well, we have three theories to this, and we can't say that one size fits all, since we can see that barrier islands form very specific to where they are. They're really unique in how they form, so one of each of these could apply to different islands that we look at. So the first theory being spit elongation hypothesis, which I know these names are kind of weird and long sounding, but we'll work through them. So if you have kind of a corner of land and the waves are hitting into it, they're moving sand through the water, and it's going to start to kind of move the sand outward and growing it out. And as you have more wave movement that's pushing more sand, it'll start to kind of trap one another and build out and out until you have a spit. You can think of Sandy Hook like this. And then as the spit continues to grow, based on storms or waves kind of washing through, you can start to have inlets opening. And this can form your barrier island chain. A second theory is submergence theory. And this is before there was water separating, the island and the mainland. It's that you had this all above water and you just had a higher ridge area of sediment. But as sea level begins to rise and continues to rise, you can get flooding that then begins to inundate this back area with water. And as that sea level maintains its height or continues to grow, then you have the separation between this higher sand ridge and the mainland, creating a barrier island system. Our third theory is the offshore bar theory, and this is just saying that as waves come in and they crash onto the shore, that they're going to begin depositing sand into an area where they're kind of crashing and breaking. And so as this happens over time, that sand patch begins to build up. And as that builds up, it soon becomes subaerial, or it becomes above the water line and forms a barrier island that we see. So we've seen how they form, and we saw a video originally showing how much they can change over time. But how exactly are they changing? What are these influences? So like I had said at the beginning, barrier islands are influenced by the energy of waves and water around them and the amount of sediment supply and sea level. So they have a lot of things going on. So sediment movement is really important, and we've seen that in a lot of videos. If you take a look at the video on the right, you can see how sand is moving out and even forming new beaches over here. So I'll play that one more time. Right here where my mouse is, you can see that the sand is building out. So this is due to something called longshore drift, that as waves hit onto the beach at an angle and move alongside it, it's kind of depositing sand. And this is going to be able to build and maintain your barrier islands and beaches. You can also have sediment movement or sand movement when you have storms occur, like hurricanes or nor'easters, since this is going to churn up waves and break away parts of sand from beaches and other land masses. You can also have sea level rise, and this is a really big factor of how barrier islands can change through time. So if you take a look at these images, especially the one on the right, you have your barrier island kind of hanging out here, but as sea level starts to rise, the barrier island is going to continuously build sediment on the lagoon side and start to migrate towards the land. And you can also see that in the left image right here. So this is a picture of a home, really stressing beachfront property. But did someone really build their home practically in the middle of the beach, right where the waves are breaking? That doesn't seem like the best investment or how you would build a house. And no, they didn't build it there originally. Obviously, they built it back, if you can remember the picture behind the dunes, where they had a whole stretch of beach in front of them. But this is just demonstrating how barrier islands can move and shift, especially on a human timeline. Another example of this is looking at this beach right here. Well, there's a bunch of dead trees. Do trees really grow on sand right next to the water? Not quite. As the sea level began to rise and start to kind of encroach on the beach and the barrier island, these trees started to die from saltwater spraying, saltwater intrusion. And so this is just both of these pictures are demonstrating how barrier islands are moving closer to the mainland as sea level rises. So here's just an image that is going to transition and show you the influence of storms and overwash on barrier islands. So look closely, this is the before picture. And here is the after. So this whole inlet is now completely open through overwashing of waves. So barrier islands, again, stressing that they're really dynamic and they really respond on short timelines. And that can cause issues, especially when we build our beach homes and communities on them. So here are just some pictures in the field. This is down in Georgia, near Tybee Island. So you can just kind of see the dune area, the large beaches, just having some fun and learning about some coastal geomorphology. And so why do we care about barrier islands? Why do we care about learning them? Well, sea level rise and storm history are actually preserved in the geologic and ecologic record. So we can do things like take cores, which is where you take like a pipe and you shove it into the ground, you pull it back up, and now you kind of have a history of a chunk of time on that barrier island. And if you remember how we were able to see the shift in time of the island moving landward in response to sea level rise, this helps us understand how quickly barrier islands and certain environments are responding to that. We also do a lot of mapping where you can see the change in shoreline, the top right image, over time, and we can better understand how quickly that's happening. And then we also have things called marsh organs where we can demonstrate under certain sea level scenarios how can vegetation and plants respond and survive. And we also care about this because we live on them. We go to the beach. It's a really large economic, cultural, social factor on us. Around 1.4 million people in the US on the Atlantic and Gulf Coast live on barrier islands. So it's a large chunk of people. This image on the top right, or this video, you can see how this is kind of building out. This is at LBI, New Jersey. And this is the area that has no development, where the human development is over here and not moving, because we've engineered it to stay put. But as we saw in the other videos and images, barrier islands are meant to move through time. They're not meant to be stable and static. And so why else do we care about them? Lots of reasons. But they protect 10% of our coastlines, so they're really widespread. During Hurricane Sandy, they actually saved us $625 million because of salt marshes and dunes protecting our property and helping the intensity of storms and waves. Marshes and mangroves also store a lot of carbon. They're carbon sinks, so this is able to help us as we put more CO2 into the atmosphere. So, with that, I'll be happy to take questions and hope you were able to learn quite a lot about barrier islands and why they're so important. Okay. All right. Let me pull up the questions that we have. Okay, so this is from Christopher Reed from Newark, New Jersey, would like to know, geology is an integrated science. There are many different interdisciplinary and specializations now. By your experience in school, what suggestions do you have for future and present undergraduate geologists on the approaches they should take when doing fieldwork and research? For instance, if a student wants to be a hydrogeologist to understand water pollution, should they look at urban development, rocks, or animals? How do they connect their research in a compelling form for the general public? So, my experience is that because geology is so interdisciplinary, it's hard to just look at one thing. I would pick an area where you feel the most interested and start there, and then start to branch out from that. Like, even though we talked about sand and not really solid rock during this entire presentation, and you would think, well, I thought geologists just study rocks. Well, it's the things that are a result of that. You know, rocks get eroded, sediments come down. That's how we're getting sand. Um, Especially if you're trying to understand hydrogeology, which is water movement, you have to understand what's going on beneath your feet, what's going on above surface, how humans are interacting with both of these things, as well as the natural component. So it's really just to spread out your information and learning as much as you can. Um, and then how do we connect that research in a compelling way for the general public? Well, I think there's a difference in how, right, when we do science, we want to ask scientific questions, and not all of them directly apply to people in a very straight path. Um, I could have framed this presentation in that barrier islands tell us about the history of storms or something, but then not really focus too much on how they shift through time. But if we kind of relate it to, well, there's a lot of economics tied with this. They save people, they help people. Um, we need to understand how barrier islands move and study them. That way, we can better predict um, what storm impacts are going to happen and how people are going to be affected. I think it's kind of how you frame things and knowing that if you're a general audience, what would you want to know about that geologic topic that's going to give someone information they didn't know before. Um, yeah, so it's just kind of doing your research and knowing your audience of what they want to know the most. Um, so let's see. Um, let's see. Mary from Scotch Plains, New Jersey would like to know, is Long Island, New York considered a barrier island? Long Island is not a barrier island. In this part of the US, a lot of things and a lot of topography was carved out by glaciers. So that actually has to do with glaciation rather than barrier island movement. But things like Fire Island and the beaches along Long Island, those thin strips, those are barrier island systems that go along it. Let's see. Rios mom would like to know, there is a hotel in Atlantic City and they have balconies, and when you look down, you can see the ocean. How safe is that? Um, well, as you could see through the presentation, since barrier islands are so dynamic, this means that they are shifting through time, and we do try to engineer it. So we have like the Army Corps of Engineers, you have private engineering companies that will go out and build hard infrastructure like jetties and groins, seawalls, and they'll build these to try and trap sediment and keep the island stable. They'll do beach renourishment where they pump sand out from the ocean onto the beach to make sure it doesn't kind of erode. Um, and they can engineer it to where it will be stable for a period of time, but it's not like the building will collapse or anything. But I think it's more so that we have to acknowledge that if we have another, well, not if, when we have another really bad storm, whether that be something Sandy like or another large hurricane or nor'easter, that is going to damage barrier islands really severely. And so when you start building, whether it be casinos, hotels, beach homes, when you start developing things like that on barrier islands, especially with sea level rise, um, they're going to be at risk. And that is a risk that you assume by building on a really dynamic place. Um, let's see. There is a lot of development in marsh areas in New Jersey. How stable is that land, and would you expect those areas to flood frequently? Well, marshes are forming in low-lying areas. So when we start to get rid of wetlands and then fill them in with like concrete or some better bedrock and then build buildings, you're kind of building already in an inherently low area, unless you start to build up your structure. But marshes, as we demonstrated, survive off of being flooded part of the time, if not most of the time. And so you come into the issue of that you're building in a flooding area, number one, and number two, they're really muddy and sandy. And so as you put more weight on that, they can compact and the ground will start to settle and compress. And that can hurt the structure of buildings. Let's see. How does climate change affect barrier islands? So, like we kind of talked about, barrier islands really, really respond to sea level rise. Um, as sea level rises, barrier islands start to migrate back towards the mainland, as we were seeing with those pictures of like the trees, the dead trees on the beach, or the house that's in the water. So they're starting to move back, but the issue is if sea level rises too rapidly, some islands can't respond to this, in which case they'll get inundated and flooded. And when they flood like that, sometimes they can't always recover, and you lose that sand and you lose part of the island. This is something called erosion, where you have water or wind or things that are kind of eating away a part of the land and it will fall off. So climate change greatly affects them, and that brings up a whole other slew of concerns because, like we said, 1.4 million people, if not more, live on them. And then we know people during the summer have their summer homes there, vacation there. There's full economies, there's cultural things we need to preserve. So sea level and climate change is a huge risk for them. How often do barrier islands change their geography, daily, weekly, or over longer periods of time? How do they disappear over time, or can they relocate? So, another thing that we kind of saw in those little videos, which shout out to Google Earth Engine. Google Earth Engine is a time lapse satellite imagery website, and you can go around like Google Maps and zoom in on different areas and see how they change through time. I think their picture span goes from 1984-ish to 2018. So highly recommend playing around with that since it's really cool to zoom in and see what is changing through time. Um, but They are changing over years, sometimes less than that. If you have a dramatic storm event where you have overwash and it destroys the dunes, obviously that can happen in a matter of hours. You have sand moving hourly and daily since, waves are always going to be hitting and breaking on the shore. Um, but you can start to see drastic changes over like 5 to 10 years. Um, Things you might notice if you can do interviews with people who have lived on the islands, and they'll kind of point out in coastal areas, that area we used to have 10 extra feet of beach, and now I don't have that. um, and it just kind of demonstrates, in combination with sea level rise, how dynamic these islands are. And they can disappear over time for sure, and they can relocate because as they begin to grow out with that longshore drift, parts of them can get cut off, and then you now have another barrier island that will migrate southward over time. How do people maintain and protect barrier islands? So I mentioned earlier places or entities like the Army Corps of Engineers or public engineering or private engineering firms. They can do things like hard infrastructure, which are the jetties and groins and seawalls. This is meant to stabilize the island and make the sand and sediment stay in place. But what's really great and is trying to be better developed and used is something called green infrastructure, where instead of building a wall, which, isn't really natural, we can start using mussel mounds and oyster shells and, shreds of coconut stacks. And these can kind of better increase sediment trapping or protect our shorelines in a way that isn't going to experience a hard failure. Because if you have a wave and it crashes into the seawall and it just collapses, that's kind of a hard failing versus having a more natural area like expanding your salt marshes where there's a lot happening with that environment and spread out area. So waves can have better time and more time to kind of slow down and not be as strong as they move through the marsh. So really building out natural areas, pretty much the complete opposite of developing further. What is beach sand made of and why can it be different colors in different places? So beach sand can be made of a lot of things depending where you are. Um, so when you see like pink or white sand beaches, that could be made from coral bits. Um, in certain areas where like if you pull up like a handful of sand and you see little like black and brown specks or maybe even like green and red, those are heavy minerals and those get eroded from the mainland, more mountainous areas. And these are minerals like magnetite or zircon or ilmenite, kyanite. And these are going to be kind of broken down from rocks and minerals. And that kind of just depends where you are. So like black sand beaches in like Hawaii, that's from the volcanoes that are right there. Versus down in Florida, you have really white sand beaches that can be from coral. So it really just depends on where the sediment source is from. So let's see. What is beach water intrusion? Does that impact humans in any way? So I don't know about beach water. I don't know if you mean flooding, but for saltwater intrusion, um, saltwater intrusion is where this can be further amplified by sea level rise. But as water begins to get into the ground beneath you, where we pull drinking water, this salt water will kind of inundate and make the drinking water that we need as people really, really difficult, if not impossible, to process and drink. And so it kind of just creates a water crisis overall. And then water management districts have to start drilling and looking for fresh water, or they have to make desalination plants. that can take the salt out of the water to make it fresh again so we can drink it. Um, and of course, this impacts people because we need water to survive and we use it every day. So if we have a shortage of that, then, that affects the community and the municipality as a whole. Um, so let's see. Are there barrier islands on the west coast of the US? Um, so like Alaska has some barrier islands. Um, the west coast has a different, I think, energy regime with the water, and it's also more rocky and gravelly. They have other morphological structures, um, like something called a tombolo, where like the sand and rocks will kind of like form this weird looking spit almost that's coming out of the coast. Though they also have a lot of cliffs and higher elevation, which make it more difficult. But you can get islands out there, but they don't necessarily form from the same processes as barrier islands. Like sand and sediment is always going to, move through water, but there have to be other controls which allow it to kind of stick and form these islands that we see. Um, let's see. Carol Drews would like to know, can you please explain more about marsh organs and how you learn from them? So, one summer I worked at Sapelo Island. This is a barrier island. It's one of the least developed ones in part of the Georgia Bight system. This is a series of barrier islands. Those are like the drumstick looking ones. And they had a marsh organ out there. And what it does is you could kind of see they look like PVC pipes, which got the name of like an organ of different heights, and they'll put little bits of vegetation in each one. And they have this in kind of like a stable area of the island or part of the island. And then what they'll do is they'll submerge it at different heights. So, like, you place it, and then you have one PVC pipe that's really small. So it's like submerged by water pretty much all day. And then as you move up to higher PVC pipes, the highest one really doesn't get any water at all unless it's like flooding. And so what it's doing, it's just kind of demonstrating what's going to happen to vegetation when it's constantly flooded, when it has no water, when it kind of has the conditions that we're used to now, where it's partially flooded during the day, partially not, and all of the different in between areas. Because, like I was explaining earlier, like marshes are filled with water part of the day because of tides, but as sea level increases and we have, differences in storms, the amount of time it's underwater is going to change in different parts of the marsh. And so the vegetation and the animal life that's really used to one environment, we have to see, are they going to be able to adapt to a new kind, or are they not going to be able to? And how can we fix this? Because we rely on the marsh for mitigating storms and storm effects, and we also, it's really important biologically. So we just look at this to better get a better understanding of what's going to happen. Didn't there used to be a South Cape May? So yeah, there actually was. There are old maps where you can see that there's like more streets that go further out. I think actually, I haven't been there personally, but I think the street that kind of stops at the water's edge is not like First Street or anything. I think it's like Eighth or something. Um, and that there was more streets and a more community out there. And as you had storms and sea level rising, it completely inundated that area. And now it's been converted into a like a marsh and a wildlife sanctuary. And I believe that's run by the Nature Conservancy. They have trails and other things out there. And it's really great how they're trying to better renovate that. Um, Pat Donahue would like to know what amount of sea level rise will cause New Jersey's barrier islands to disappear? Um, so I don't know an exact number, because it's also going to depend where you are in New Jersey, because there is technically a difference in rates of sea level rise near Sandy Hook versus those near Atlantic City, and that has to do with the underlying geology. Um, but I will make this a plug for a really wonderful website that was developed by other Rutgers people. It's called NJ, as in New Jersey, NJ Flood Mapper. This website, njfloodmapper.com, actually lets you plug in different values of sea level rise. It lets you look at storms. And you're actually able to see on a map what gets flooded through time and the amounts that it gets flooded. And that's just another really cool tool that you can play around with and look to better see, okay, well, under this scenario of this many feet of sea level rise, I noticed that half of LBI is gone. And so that lets you better manipulate and understand what amount is going to start inundating and flooding these areas. So let's see. Even with beach nourishment, doesn't the beach still get eroded? Do you think it is better to use those funds for some other way to help protect the beach? Yes. I this is something I'm really interested and passionate about and learning about is what are our other options? I think I think the Army Corps and the state of New Jersey throws millions of dollars, I think, every year into beach renourishment. Because, like we were saying, like with longshore drift and just naturally how the earth and ocean and sand and everything interact, they're moving through time, they're really dynamic. And by trying to make it stay in place, the beach or islands, we have to put a lot of work and energy into that by pumping sand back or building these hard infrastructure. So it is still getting eroded no matter what we do. So we're not actually stopping erosion by doing any of these things. We're kind of just prolonging the lifespan of these areas. And I think it's better to use those funds for some other way. Yeah, so actually, and this is, it's a controversial thing, but you have these beach towns and these beach areas where, they have communities, you have your summer home, you go and you hang out there at the beach. And you have these hotels, condominiums, beach resorts. And they're kind of right up along the beach or they're right up along the shore. And by doing this, it doesn't allow dune systems to fully form. We also have to destroy wetlands to build up on this. And when you get rid of these natural hazard mitigators like the dunes and marshes that nature builds to protect that area, and you get rid of them, it's not going to be as strong as what it once was. So I think we should invest more in green infrastructure and doing areas and kind of putting this area. We need more area between the beachfront and people. So kind of reverting things back to salt marshes and sand dunes. Let me see. Did you always know that you wanted to be a paleoceanographer / geologist? No. I discovered geology. Well, I wanted to be a paleontologist when I was a kid because dinosaurs are awesome. And answering two questions, I like Allosaurus because it was in a lot of the Walking with Dinosaurs videos I would watch. A lot of dinosaur documentaries. And I've always been interested in paleontology. But around my sophomore year of undergraduate and college, I just ended up taking a class and the people were really great. And I had always liked history. And I also like science and I like learning about the natural world. And I'm like, okay, well, geology is the history of the earth. So get the best of both worlds there. And, I like understanding what's going on around me and all of the things that control how we live and how we influence that. Um, and then I've always just been attracted to the water and the coast, especially growing up in Florida. I lived about 30 minutes from the beach. And I like that interaction between humans and the environment. And like I said, being able to study things with water, the coastlines, are that very few lucky times to be able to observe geology in our lifetime. Because when you think of geology, we're thinking of like, oh, something happening over a million years is short. But, looking at coastal morphology, within 20 years, we can see change. Another question. Where have you traveled for your research? So in undergraduate, I worked and lived for a summer on Sapelo Island. So I actually had to like take a ferry out there. And it's pretty remote. And that's in southern Georgia. Um, I've been in a lot of marshes, so a lot of stinky areas, but they're fun to study. Um, and then for something that all geologists have to do if you're an undergrad is something called field camp. And this is probably one of the greatest things about doing geology for undergrad, is that you get to go to different parts of the United States and study the geology there for a few weeks. So for mine, we went to the Southwest, and I got to go throughout different states in the Southwest US to do projects and work. And final question is, what do you think is the biggest threat to barrier islands and what can we do about it? Um, Definitely sea level rise and climate change. Um, so what can we do about that? About climate change and sea level rise? At this point, we are going to experience it no matter what we do right now. Um, so the biggest thing is we need to prepare for that and we need to plan for these things. And by planning and taking action, that means starting to think of better ways to organize our communities, maybe going back and having more natural areas in front of us, like stopping development in certain areas, or if we can, starting to reverse development. It's really just promoting more of the nature, and better being able to plan our communities not directly on the island on the water, since they will get flooded through time. But we have the ability as a state and as, through governments and institutions and communities to plan for these things. And there's a lot of really great resources out there, a lot of things through Rutgers and through the state Department of Environmental Planning and other organizations that are working to have different plans that are really specific for their communities. So it's kind of not necessarily a one size fits all, but we know we need to start planning now for the effects we'll face in, 20, 30 years. So,
Okay. Oh,
yeah.
sorry. Go ahead, Ashlyn.
If that is the last question, just wanted to check in with you, Ria.
Yeah, so thank you, Ashlyn. That was great. And so thank you for everyone joining us today. And don't forget to join us on next Tuesday, June 23rd at 2 p.m. We will have Christina Verhagen. She's a graduate student at Rutgers in the Department of Earth and Planetary Sciences, and she will be talking about the impact that killed the dinosaurs. So that is on Tuesday. And thank you once again, Ashlyn. And for anyone who wanted to check out that flood mapper that Ashlyn was talking about, the link is in the chat, and we can also put it up on our website as well. So thanks again, Ashlyn, and have a great day.
Thanks, y'all.